Hello students, myself Professor Ashok M Jain. In this lecture, I am going to talk about two numericals. Okay, and here I am going to talk about I have taken R, L, and C. All these three elements are connected in series, and we are going to find the transient response by using classical method. So this is the numerical on network equations using classical method for RLC circuit. Okay, already I had discussed one numerical in lecture number 7 also along with the theory. So here we are going to talk two numerical. So this is the first numerical we have for the series RLC circuit with the capacitor initially charged to 1 volt as shown in figure. Find the expression for the current. तो एक काम करता हूँ मैं इसको in place of that 1/2 farad 1 volt already charge है तो मैं ऐसा कर लेता हूँ. In place of that I am going to show 1 volt here. Clear? And in place of that, this is R, L, C. R is 2 ohm, L equal to 1 Henry, and C equal to 1/2 farad. And already it was 1 volt charge था तो 1 volt का source लगा दिया. So both are same problem. And I'm closing the switch at t equal to 0. Clear? So both are the same problem. So please see here before the t equal to 0. So I L0 minus equal to IL0 plus equal to I0 equal to something. Similarly, VC0 minus equal to VC0 plus equal to VC0 equal to. Now see here, I am assuming in this diagram, switch was open. If the switch was open, what was the current flowing? 0. Or current flowing 0. So just before operating the switch current was 0. So just after operating the switch, current will be 0 because inductor opposed the change of current. Clear? Similarly, voltage across capacitor just before what was the voltage across capacitor 1 volt था. तो just after कितना रहेगा 1 volt. तो यहाँ 1 volt दिखाओ या in place of that I am going to show 1 volt source. So capacitor I will show it is not charged. So just before capacitor voltage was 0. So just after capacitor voltage would be 0. Clear? So it is again 0. So these are the two initial conditions we have. Now at t equal to 0 I am closing the switch. Closing the switch and write the KVL. So when you write the KVL क्या आएगा? L di by dt. L मतलब 1 di by dt plus ri. R मतलब 2 into I. 2i plus 1 by c. 1 by c कितना है? 1/2. 1 by c integration of I dt equal to please see here equal to अगर आप ये डायग्राम देखेंगे तो यहाँ equal to no source तो 0. लेकिन आई एम गोइंग टू शो हियर सेकंड डायग्राम तो ऑलरेडी ये सेपरेट शो किया है तो इट इक्वल टू व्हाट 1 वोल्ट. इक्वेशन नंबर 1. नाउ this is a integro differential equation. This is integration, this is differentiation. So I am going to differentiate it. So you will get after differentiating d squared by dt square आएगा plus 2 डिफरेंशिएशन ऑफ आई क्या आएगा डी आई बाई डी टी. सो डी आ जाएगा आई कॉमन ले लेंगे प्लस ये 1/1/2. सो 2 ऊपर आएगा सो 2 आई यू विल गेट इक्वल टू differentiation of 1 is constant. So differentiation of constant is 0. Okay, so I am getting this equation. Okay, now you can say I have two roots. दोनों का सम कितना चाहिए 2. ओके एंड दोनों का मल्टीप्लिकेशन 2. सो 1 plus 1 2 तो okay, but 1 into 1 is 1 ही होता है, so something is wrong here. So you can use the वही मेथड है ना, माइनस बी प्लस माइनस बी स्क्वायर अंडर रूट ऑफ बी स्क्वायर माइनस 4ac अपॉन 2a, उस मेथड से आप you can find two roots. Otherwise if you use the calculator you can find the two roots. So I'm getting the two roots d1 and d2 equal to, just I'm going to use the calculator. I'm going to use the calculator. I'm getting, yes, I'm getting minus 1 plus minus j1. I'm getting complex conjugate roots. Please be careful about it. If you are going to use the calculator, वहां पर आपके दोनों रूट माइनस वन दिखा देगा, बट कैलकुलेटर के मॉनिटर पे इफ यू सी कॉर्नर में कहीं आई नाम का एक वर्ड दिखेगा, सो इससे आपको पता चल जाएगा इट इज ए कॉम्प्लेक्स कॉन्जुगेट रूट. और मैंने आपको पहले बता दिया सम दोनों दो चाहिए और मल्टीप्लिकेशन दो चाहिए, सो इट इज नॉट पॉसिबल. सो इट इज ए कॉम्प्लेक्स कॉन्जुगेट रूट. बी केयरफुल अबाउट इट फॉर फाइंडिंग. नहीं तो आप मालूम चला दोनों का माइनस वन आ गया, आपने ले लिया दोनों रूट रिपीटेड एंड रियल. Okay, so it is not correct. Okay, so I got it. Since roots कैसे, roots are complex conjugate. Okay, so we have a root solution I equal to what? What is I equal to? E raised to minus alpha t. E raised to minus alpha कितना, minus 1 minus e raised to minus t in bracket k1 cos of beta t. k1 cos of beta कितना है, 1. t1 cos of t, beta means 1t plus k2 e raised to minus, sorry, e raised k2 sin of, sorry, k2 sin of beta कितना, 1 beta t. So I got the solution. Question number 3. Okay, since here we have two unknowns, this is the general solution. This solution is called as general solution. Why it is called a general solution? Because ये जो solution है ना, by just observing the roots you can write that solution directly. This solution they have proved in mathematics. Okay, और हमारा application part है, so I'm not interested in the derivation. So directly you can write this is the general solution because it is in terms of k1 and k2. We can find the k1 and k2 can be obtained from where? K1 and k2 can be obtained from initial condition. What is the initial condition? At t equal to 0, I equal to कितना है, 0 है, और v equal to क्या है, वो भी 0 है. देखो you can see these are the two initial conditions, right? So we will put it and we will try to get the answer. So I'm going to use separate sheet. So I'm rubbing it first. Okay, now so I'm going to use this solution. I got the formula. Question number 3 I got I equal to what? I got I equal to e raised to minus t in bracket k1 cos of t plus k2 sin of t. Question number 3rd we got. Okay, now we will find the k1 and k2 from initial condition. So from initial condition, what is the initial condition? At t equal to 0, what is our current? I equal to 0. Okay, so at t equal to 0, I equal to 0 equal to e raised to 0 k1 cos of 0 plus k2 sin of 0. So e raised to 0 is 1 equal to e raised to 0 is 1, k1 cos of 0 is 1, k1 into 1 plus k2 sin of 0 is 0. So equal to what? 0 equal to k1. This is 0, k1, k1. You will get k1 here. So I got k1 equal to 0. So I got k1 equal to what? 0. तो एक काम करते हैं, आई एम मॉडिफाइंग इक्वेशन 1. मॉडिफाई 1. If you modify the equation number 1, क्या होगा? If you modify the equation number 1, क्या होगा बोलो? Sorry, modify the equation number, not 1, 3. Modify the equation number 3, so I am getting I equal to e raised to minus t. k1 की वैल्यू कितनी आई है? 0 आई ना. I got k1 equal to 0, so ये टर्म 0 हो जाएगी. So e raised to minus t, k2 sin of t. I got equation number say 4, modified equation आ गया. That is a solution. Again it is in terms of k2, so it is a general solution. But k1 0 है. Okay. Now we want to find k2 again. So how will you get? एक काम करता हूँ मैं इसको differentiate करता हूँ. Differentiate 4. Differentiate equation number 4. When you differentiate equation number 4, yes, क्या आएगा? क्या आएगा? di by dt. If you differentiate this 4, so di by dt, I am taking equal to one constant, k2 constant लेता हूँ मैं. k2 constant लेंगे तो this is u, this is v. u into v का differentiation है, तो क्या आएगा? e raised to minus t, keep u, dv. dv क्या आएगा? साइन का डिफरेंशिएशन क्या होगा? cos of t. क्लियर? प्लस इसका du sin t एज इट इज, v du का डिफरेंशिएशन क्या होगा? माइनस e raised to minus t, और इसको एज इट इज रखेंगे sin t. राइट ना? ये du into v है ना. सो क्या रखा हमने? क्या रखा? इक्वल टू क्या आएगा? u dv प्लस v du. क्लियर ना? ये आ जाएगा इसका डिफरेंशियल. एनीवे, सो ये आपका आ गया di by dt equal to this. So let us say equation number 5. Okay, now this is equation number 5. Put initial condition here. अब initial condition मतलब क्या है? di by dt 0 प्लस रखना है. So we can find di by dt 0 plus from equation number 1. From equation number 1. So just I'm going back. Equation number 1 देखो आप क्या है? ये equation number 1. ये di by dt 0 plus. यहाँ पर equation number 1 में I की वैल्यू कितनी है? 0. So this is 0. Whole term, this term represents the voltage across capacitor, right? This shows the voltage across capacitor. So this is what? 0. So ये whole term 0 है, I 0 है, so you will get di by dt 0 plus. Okay, क्या आएगा? I'm just going back. So from 1, so di by dt 0 plus ri. R into I कितना है? 0. So 2 0 plus whole term Vc, it shows G, sorry, equal to कितना है? 1 था. Okay, so you will get from here, you will get di by dt 0 plus you will get ये 1 और ये कुछ नहीं, 1 ही आएगा. 1 volt ampere per second, 1 ampere per second. Okay, so I got di by dt plus. So this value di by dt 0 plus we will put in 5. So this is 1, di by dt 0 plus is 1 equal to what? K2 e raised to minus 0 at t equal to 0. At t equal to 0, I am putting it. Okay. So at t equal to 0, di by dt 0 plus is 1 e raised to 0 cos of 0 minus e raised to 0 sin of, sorry, sin t is that, sin of 0. Sin 0 is 0, so this term will be 0. Sin 0 is 0, so okay, cos 0 is 1, e raised to 0 is 1. So from here, e raised to 0 is 1, cos of 0 is also 1. This will be sin 0 is 0. So k2 equal to क्या आएगा? K2 equal to, I am getting 1. So put this value K2 in equation number 4. Put the value of K2 in 4 in equation number 4. So you will get I equal to, from 4, I am getting I equal to what? I equal to e raised to minus t. K2 कितना है? 1 sin of t. That is a solution I am getting it. That is a solution I am getting, e raised to minus t sin of t, right? So from classical method, you will get the solution I equal to e raised to minus t sin of t. But if you do it by Laplace transform technique, this will give the simple solution. Okay, but anyway, they have given find the current by using the classical theory, so we have to do it by classical theory. Okay, so this is the solution. So how to do it? पहला काम क्या करना है आपको? पहली कंडीशन क्या है आपका? Just wait, sorry. पहली कंडीशन क्या है? इनिशियल कंडीशन निकालना है. Then after closing the switch, you have to write the KVL, then differentiate it, then you will find the two roots, and based on the two roots you will get the general solution. And then we have to find the value of K1 and K2 from the initial condition, and once you know the value of K1 and K2, you will get the particular solution, right? I'm rubbing it. I will solve one more problem. Okay, so I'm going to solve one more problem, example number 2. This is the problem I have given. Close the switch at t equal to 0. Find I at t is greater than 0. So general solution I have to find. So first of all, initial condition. Before t equal to 0, switch was open. Switch was open, so I L 0 minus equal to I L 0 plus equal to I 0 equal to what? 0. Switch was open, so current was 0. Similarly, जब स्विच ओपन था तो करंट फ्लो ही नहीं हो रहा था. करंट फ्लो नहीं हो रहा था, कैपेसिटर वाज नॉट चार्जिंग. सो Vc0 माइनस इक्वल टू Vc0 प्लस इक्वल टू Vc0 कितना है? 0. So these are the two initial conditions, right? At t equal to 0, close the switch and write KVL. Okay, so I'm writing the KVL. So what is the KVL? L di by dt. L कितना है? 1. L is equal to 1. So 1 di by dt. So I'm getting di by dt into 1 plus Ri. R कितना है? 4. Ri 4i plus 1 by C. C कितना है? C कितना है? 1 by 4. Integration of I dt equal to voltage source 1 volt. Equation number 1. So differentiated this and put d by dt के बदले में क्या लिखेंगे? D square. When you differentiate it, because it is an integral differential equation. This is integration, this is differential equation. So it is better to differentiate it. So when you differentiate, यहाँ पर आ जाएगा d square by dt square I. So d square के बदले में लिखेंगे d square plus यहाँ आ जाएगा 4 di by dt. di by dt के बदले में d plus 1 upon 1 by 4 मतलब 4. क्लियर? और यहाँ आएगा I कॉमन इक्वल टू, यहाँ क्या आएगा? 1 का डिफरेंशिएशन 0 होता है. Clear? So this is equation number. Okay. Next, you can see two roots you will find. दोनों का सम 4 है, दोनों का मल्टीप्लिकेशन 4. सम 4, मल्टीप्लिकेशन 4, राइट? क्या आएगा बोलो? I have two roots. The sum of these two roots are 4, and multiplication is 4. So sum कितना आएगा? 4. Multiplication 4. How it is possible? Yes, 2 and 2. 2 plus 2, 2 plus 2, 4. 2 into 2, 4. So right, I had two roots. D plus 2, you can say square of that, equal to 0, right? So d square plus 4d plus 4. So we will get two roots. कौन कौन से roots आएंगे? d1, d2. I am getting two roots, minus 2, minus 2. So I am getting two roots. Both roots are minus 2, minus 2. इसका मतलब both roots are real and repeated. Real and repeated. Roots are real and repeated. So solution क्या आएगा? I equal to direct solution है k1 plus k2 into t, k1 plus k2 into t e raised to minus alpha t. Alpha कितना है? minus 2t. That is a ready-made solution we have. k1 plus k2t, okay, e raised to minus this. Okay, this is the equation number 2. Now this is called a general solution. This is called as what? General solution. This is called a general solution. And if you know the value of k1 and k2, you can get the particular solution. So k1 and k2 can be obtained. K1 and k2 can be obtained from initial condition. What is the initial condition? At t equal to 0, I equal to 0, and at t equal to 0, Vc is 0. That is the initial condition, right? At t equal to 0, I equal to 0 है, and Vc equal to also 0. That is the initial condition. So we will get the k1 and k2 from there. So I'm going to use the next sheet. First of all, I'm rubbing it. Okay. I'm going to use this. I'm going to use one solution. क्या था? एक पहले आया था equation number 1, di by dt plus 4 plus 4i plus 4 integration of I dt equal to what? I got 1. This was the equation number 1. Second equation I got I equal to what? I equal to what? K1 plus K2 t e raised to minus 2t. This is equation number 2 I got. This is the general solution. Okay, so we can find the K1 and K2 from initial condition. So at t equal to 0, I equal to what? 0. So this put this value here in equation number 2. Okay, at t equal to 0, I equal to 0, put in 2. So I equal to what? 0 equal to k1 plus k2 into 0, t equal to 0. Okay, e raised to 0. So e raised to 0 1, k2 term 0 है, तो ये 0 हो जाएगी. k2 into 0 means 0. So k1 from here I am getting k1 equal to I am getting 0. देखो ना, ये तो 0 ही है. So k1 plus 0 equal to 0. So k1 equal to 0. So I equal to modified equation of I. Modified equation. Modified A. I equal to what? K1 0 है. So K2 t e raised to minus 2t. Let us say 3. I got 3. That is a solution. Again, this is a general solution because T2 is not on. So how to find? So एक काम करता हूँ मैं, differentiate 1. Differentiate 1. Not differentiate 1, sorry. Differentiate 2. Not 2, 3. Because इसकी जरूरत ही नहीं है, इसमें तो केवल नहीं है. Differentiate 3. Right? This is U. This is V. U by V का differentiation है. Right? Differentiate 3. And after differentiating this, we will get it. So when you differentiate 3, क्या आएगा? Di by dt. Di by dt equal to K2 constant ले लेते हैं हम. Just wait. हम K2 constant, right? So this is K2 constant लिया तो क्या आएगा? Bracket में U as it is T U dV. इसको differentiate करेंगे तो माइनस क्या आएगा? minus 2 e raised to minus 2t. Okay, प्लस v को एज इट इज रखने का, इसको डिफरेंशिएट करने का, v मतलब इतना एज इट इज रखने का, e रेज टू माइनस 2t एज इट इज रखने का, और इसको डिफरेंशिएट करेंगे तो क्या आएगा? t का डिफरेंशिएशन क्या होता है विद रिस्पेक्ट टू t1. सो आई एम गेटिंग k2 di by dt कितना आ रहा है? di by dt कितना आ रहा है? k2 e रेज टू माइनस 2t कॉमन ले लो. e रेज टू माइनस 2t कॉमन लिया तो क्या आएगा? ब्रैकेट में minus 2t from here, और यहाँ से plus 1. Okay, so this is equation number say 4. This is equation number 4. Now from this one, find di by dt 0 plus at t equal to 0. From 1, di by dt from the initial condition, di by dt 0 plus, I am finding at 0 initial condition. So di by dt 0 plus equal to क्या होगा? 4. I की वैल्यू कितनी है? 0 प्लस ये होल टर्म क्या शो करती है? वोल्टेज अक्रॉस कैपेसिटर कितना है? वो 0 ही है ना, इक्वल टू 1. सो आई एम गेटिंग di by dt 0 plus this di by dt 0 plus equal to what? 1. Okay, so I am getting di by dt 0 plus 1. So this value di by dt 0 plus we will put here. Okay, so I am putting here. So di by dt 0 plus at initial condition, so it is 1. We are putting here 1 plus equal to k2 e raised to 0 t equal to 0 पे a di by dt 0 plus 0 है. Okay, 1 है. Minus 2 t equal to 0 at t equal to 0 plus 1. So I am getting e raised to 0 1 होता है, so k2 आएगा, ये 0 हो जाएगा, so k2 equal to 1. So from here I am getting k2 equal to 1. So this value of k2 we will put in modified equation. कौन सा modified equation? 3. Put this in 3. That is the modified equation. So I equal to क्या आएगा? देखो I equal to 3 कहाँ है? ये I equal to k2. k2 की वैल्यू कितनी है? 1. t so I am getting I equal to what? T into e raised to minus 2t. This is the solution. Okay, so this is the amount of current is flowing, t into e raised to minus 2t. Okay, so I have solved two numerical based on the RLC circuit. That is the classical method I have used. Clear? And we got the solution, current in the time domain. Okay, so I am coming back. Okay, so this was the problem. First initial condition, then we have written the KVL after closing the switch. Then I got the roots. Based on the roots, I got the general solution, and from the initial condition we got the value of k1 and k2, and we got the particular solution. Okay, now I'm rubbing it and I'm closing here. In the next lecture I will discuss what is the initial condition and what is the final condition, and after discussing I will take one numerical based on initial condition and final condition, and one more lecture I will discuss some numerical based on the initial and final condition. Clear? So these are the two lectures will be required for completing this part, and then I will discuss MCQs based on that. So I'm going to develop 3 sets of 25 questions, means total questions will be 75. We'll discuss the MCQ. These MCQ questions will be useful for the GATE examination, as well as it will be useful for some competitive examination. Okay, so I'm stopping here. Thank you very much for listening me carefully. Thank you.